Hi guys, welcome back to another video. Today we're going to be looking at the law of indices. So there are three main laws when it comes to indices, and so let's have a look at the first one. So here it says a to the power of m multiplied by a to the power of n. Essentially what that means is we're just adding our powers together. So we would say that a to the power of m multiplied by a to the power of n is a to the power of m plus n. So whenever we multiply our indices or our powers, we add them together. So that's our first rule. So if we know when we multiply, we add our powers together. When we divide, it must be the inverse or the opposite. So if we add, we then subtract. So a to the power of m divided by a to the power of n is a to the power of m minus n. So we know from our first rule that whenever we multiply our powers or our indices, we add them together. And now we know that when we divide, we take them away. And then the last one is when one indice is inside the bracket and one indice is out. All that means is now we just multiply them together. So a to the power of m n it becomes. So we've learnt the three basic rules. And the three basic rules are whenever we multiply our indices, we add them together. Whenever we divide, we subtract them. And when one is outside the bracket and when one is inside the bracket, we then multiply them together. Let's now look at three examples of how we can apply our rules. So the first question states to simplify m to the power of 5 multiplied by m to the power of 3. Well, we already know that whenever we multiply our indices, we add them together. So what we're just doing is m to the power of 5 plus 3, which is then m to the power of 8. So we've applied our first rule of multiplying indices. Now the second question states to simplify m to the power of 8 divided by m to the power of 2. Well, we know our second rule states whenever dividing our indices, we therefore subtract. So we know m to the power of 8 divided by m to the power of 2 is essentially just saying m to the power of 8 minus 2, which is m to the power of 6. And now the third question, we've been asked to simplify m to the power of 3 in brackets to the power of 2. And according to our rule, we remember that whenever one indice is inside the bracket and one indice is out, we're just going to multiply it. So essentially what we're being asked to do is m to the power of 3 multiplied by 2, which is m to the power of 6. And we've used our laws to basically answer three simple questions. But now we will move on to the more complicated questions where we will be asked to use our laws in different ways. So now let's move on to a more complicated one. So it's asking us to simplify a to the power of 1 over 5 multiplied by a to the power of 2 over 3 divided by or over a to the power of 3 over 5. So it may seem complicated, but let's split it up. So our first step is to deal with the numerator. So since we're multiplying powers together, we already know we need to add them together. So it's just a simple addition of fractions. We're going to find the common denominator for both. So what we can do is multiply both sides by 3 and both sides by 5. So we know that 3 over 15 plus 10 over 15 is 13 over 15. So we know when we deal with the top, we're left with a to the power of 13 over 15. And we've reached that conclusion because we can see that at the top, we're multiplying. So since we're multiplying, we need to add our powers together. And our powers are both fractions, so we added them together. And we got 13 over 15. And now we've been asked to divide it by a to the power of 3 over 5. And we know that whenever we divide powers, we subtract. So what they're asking us to do is subtract 13 over 15 from 3 over 5. And this is then, again, basic subtraction of fractions. So we find a common denominator and we can see it's 15. So we're going to multiply this fraction by 3. And that will give us 13 over 15 minus 9 over 15. And we know that's going to be 6 over 15. And so since we've now worked out what our final indice will be, we can just put it to the power of a. And there you have it. So we're now going to look at another difficult example. So we've been asked to work out the root of 50 pi a to the power of 5 divided by 2 pi to the power of a to the power of 3. So our first step is to ignore the root for now. Let's just write it as a normal fraction. So 50 pi a to the power of 5, 2 pi a to the power of 3. So we're just going to use simple division to work out the first two parts. 50 pi divided by 2 pi. The pi's will cancel out. And then we do 50 divided by 2, which is 25. And now when we move on to a, we can see we've got a power. A is to the power of something. So as soon as we see the power, we know we're dealing with indices. And we know, according to our rule, that whenever we divide, we subtract our indices. So simply, we're just going to do 5, subtract 3, which is 2. So when we divide this fraction, we get 25a squared. Now, second step is to remember that we can't forget the square root. We've just ignored it for the first part, but now we need to bring it back in and square root the answer we got from it. So square root simply means what will multiply by itself to give us 25a squared. So we know that would be 5a, and that's because 5a multiplied by 5a is 25a squared. And so we've been able to simplify fully a quite complicated looking fraction with a square root involved. That now brings us to the end of the video. Thank you everyone for watching, and make sure to like, share and subscribe, and please comment what other topics you would like me to do. Thank you.